Hello, everybody. Thanks for coming. My name's Joe. I'm the client platform engineer team at Facebook. And what I want to talk about today is Chef, what it is, why you would want to use Chef or any other configuration management tool, and a little bit about how we customize and use Chef at Facebook using our API model to distribute our workload out to our end users. This is an alternate title. My wife pointed out and that she's very disappointed in me for missing out on an obvious pun here, and I'm filled with shame. So I'm going to leave this on the screen for a minute. At the end of the talk, there's going to be a short demo. You can follow along, try it out on your machine, ideally in a VM. I posted this link to the sumac deans to list. And also, if you're like me and you pronounce PSUmac sumac with a silent P, there's also a plant called a sumac. And the name translates to turning red. There's also a species called poison sumac that I guess you East Coasters are aware of. It can cause skin irritation, difficulty to breathe. And the only reason I bring this up is because it's an irresistible metaphor for people like me who are terrible at public speaking. And hopefully this has been long enough. I posted it in the regular PSUmac channel as well. Okay. So what is Chef? Well, it's an API to configuration management, which is a boring way of saying that Chef abstracts configuration management settings into a consumable format that is easy to interact with. But really, I think a better way to put it is to say that it's a framework for defining your infrastructure as code. And your infrastructure can be anything like a rack of servers, a cloud system, a network device, or in the case of the purposes of this talk, a boatload of client devices like Macs or PCs. By providing you with a standardized interface, Chef allows you to make safe, repeatable, and automated changes to your configs. And rather than having to know how to write low-level C code or anything to interact with the OS, you can use Chef's easy-to-discern DSL or domain-specific language in Ruby to express the management settings that you want to apply to your systems. Why Ruby? I think it's because it's to irritate those of us who just now barely managed to learn a little bit of Python. But Chef's use of Ruby means that you can take advantage of the language's strengths by iterating over arrays or hashes using the built-in APIs, built-in Ruby objects. And because Chef is built on a DSL or a domain-specific language, you don't necessarily have to know Ruby to write any Chef cookbooks. You can express your code as blocks of Chef-specific Ruby. And Ruby and Chef will translate that into the code needed to manage the machines. Chef is open source. You don't need to sign up or pay anything. You can just download it and off you go. And that's how we'll be doing the demo later. We'll just be installing Chef Client, pointing it to a couple of config files locally in the system, and hitting go. Of course, you can pay for Chef if you want to. They offer a hosted service. You can host your own Chef servers on-prem if you want, or you can go with a serverless model or what's referred to as Chef Solo, which again is how we will be handling the demo later on in this talk. In the hosted or Chef server model, your clients interact with the Chef server over a REST API. This uses straight up TCP sockets over HTTP. There's really nothing fancy in how the client communicates with the server in that aspect. Chef operates on a so-called thick client or thin server model, where the public key is stored on the server each node or each client has a private key that it uses to generate a secure communication to the server when it makes a connection over the API. And then the client downloads all the configs, all the policies, all the cookbooks, and processes everything locally. So this makes the server product highly scalable and performant. So what's the big deal? You may be able to just include configuration profiles in a base image, apply it to your systems. You may have a method for delivering scripts that you can run on your systems at a given interval. Well, Chef and other config management systems, they won't just run scripts over and over and over. They tend to be a little bit smarter about that, and you just simply describe the desired managed state that you want of the system, and Chef will decide whether that process needs to be run or not to bring the machine into compliance. So if a setting does not meet that desired state, Chef will make sure it does. And then if that setting changes in between runs, it'll change back. If that setting already exists, then Chef will just go right past it and not do anything. By using a custom DSL, the domain-specific language, Chef abstracts a lot of that work that you would have needed to put in to manage your various endpoints. For instance, at Facebook, we have a CPE profiles resource in Chef that we can use, and all you need to do is just describe the state of the profile that you want. So you just say, these are the settings I want, this is the name, this is the preference domain, and the CPE profiles resource will gather all that information, build the profile for you, install it, manage it, make sure it's installed on subsequent runs, and later on, when you decide that you no longer want to manage that preference, then Chef will remove that profile from the system for you. Order matters in Chef, which is something that differentiates itself from some other config management programs. I'll get into this a little bit more later, but I just wanted to point out that because we can define the order in which Chef processes the cookbooks and recipes, we can be very determinative and predict how those settings will be applied to the systems. Due in large part to the open source nature of Chef, the community has developed and shared many useful tools, making it easy to collaborate with your colleagues and share cookbooks and resources back and forth. At Facebook, we try to write all of our cookbooks with the community in mind and publish those cookbooks to GitHub. Sometimes it's not possible because of internal considerations, but we do publish quite a bit of our work on our GitHub. Others in the community, such as Pinterest recently, have been doing the same. As a result, many of these helpful tools have been developed, some by the community and some internally at Chef, and are now available to the community at large. Supermarket is a location, it's a site where you can go to download and try out community cookbooks that are hosted and managed centrally. Test Kitchen will automatically test your cookbooks for you with any combination of settings, and is cross-platform testing for you as well. The Chef spec you can use to kind of simulate a Chef run on a node, and Food Critic will just nag you about your syntax until you type in the correct letters in the correct order. And a lot of the stuff you'll notice is in the Chef world is food pun related. So we all just, we find it so delightful. If you ever are going to contribute, develop a tool for Chef, please make sure it's a pun based on food, because we love it. It's great. Chef Server is a hub for your configuration data. Stores all the cookbooks and recipes and attributes and policies that are used to apply changes to the systems. Also stores metadata of all the nodes and can make decisions based on that metadata. The Chef client accesses the Chef server from the node on which it's being used, might possibly register itself with the Chef server, and then downloads everything that needs to be changed. This work is done, again, on the client and not the server, making Chef Server very scalable. At the end of a run, the Chef client will post back run data and status back to the Chef server, which stores that in the metadata of the node so that that data can be used on subsequent runs. A node is just a client. It could be a physical or virtual server, a cloud system, a network device. For our purposes, we talk about it in terms of client devices, Macs and PCs, laptops and desktops. Chef client on the node performs all the configuration tasks that are specified within your Chef run list, and will pull down any required configurations from the server, and caches everything locally and checksums everything. So it'll only pull down the changed cookbooks that need to be applied on another run. So it's not just grabbing everything on every run, making it very scalable in that sense. Cookbook is kind of the fundamental atomic unit of your configuration and policy. Cookbook defines the scenario that you want to manage and contains everything that's needed to support that scenario. Recipes, a cookbook contains recipes that specify resources, that may call providers to affect changes in your system. It'll contain attribute values that you can use to make decisions about what needs to be configured or installed. A cookbook can contain files that are copied down to the node in a specific path, can contain templates that are used to create files locally, and other extensions such as libraries and resources, custom resources that you may write on your own to affect some changes on the systems. If you're familiar with Ruby at all, a cookbook is kind of analogous to a Ruby gem. It's a self-contained package. It can be passed around. It can be shared. It can be interdependent on other cookbooks or other recipes, or it can just be its own thing that you run, that you include in your run list to run on your nodes. Recipes inside a cookbook are a collection of resources that are executed to configure a node. Recipes must be added to the run list before it can be used by Chef client and are always executed in the order in which they appear in the run list. So again, we can predict the order in which Chef configures your machine. Recipes can be interdependent as well. They can call other recipes. They can call resources from other recipes. And they're used to define that desired state that you want for your systems. When Chef client runs the same recipe over and over, the results will always be the same because of that idempotency of the config management system. Resources are little abstractions of configurable bits that describe, that you use to describe that managed state that you want. You can declare the steps needed to bring the node to your desired managed state. And an example of this, of an internal resource in Chef is the user resource, which will manage users. They'll create the user, specify the home directory path, the UID and the GID, and you can customize all those little bits in there. And every time Chef runs, it'll ensure that user is alive and available on the system. If any of those attributes are missing, it'll re-add it. If something gets changed in between runs, Chef will make sure that it gets back to that managed state. Some examples, other examples of resources are like package resources, which you can use to install Linux software, for instance, or a service resource that you can use to manage services on your systems, like Apache. You can also write your own custom resources if what you need is not available built into Chef. Facebook, we have written, or Nate and Mike have written many open source custom resources. There's one for LaunchD and one for profiles, and all you need to do is just provide the resource with the information that you want in a LaunchD job, for instance. You tell it what the program path is, the frequency of the run at load, true or false, and then the LaunchD resource will gather all the information, build the LaunchD for you, load the service, make sure that service continues to run on subsequent Chef runs, and in the event that you no longer want to manage that LaunchD job, you remove it from your run list, Chef will notice that it's gone, will stop the process, remove the P list, and that job won't run anymore in the system. Attributes describe node settings. When a cookbook is loaded during a Chef client run, these attributes are compared to attributes that already exist in the node object. And again, because of the declarative order in which Chef runs, we can kind of tweak it to make sure that the values of these attributes match what we want to for that particular machine. When the cookbook attributes take precedence over the default values, the last value wins because, again, it's running in a predictive order. Files can be transferred down from the Chef server, from the server to the client in a specified path, and you can describe other managed attributes for files like the user owner and executable bits in the path to store the file and to ensure that the enclosing directories exist. Templates are little embedded Ruby blocks that can be used to dynamically generate files, and you can include pure Ruby code in a template to iterate over an array, for instance, to customize a file on disk. An example of that would be if you wanted to manage your host file, your Etsy hosts. Some systems might need to have different lines in there than others, and so Chef can make that determination and iterate through an array and include all of the lines in the host file on the system on which it's being run. Depending on the type or location of the file or of the machine, you may want different applications to apply to different systems. And so templates are a great way to do that when you're managing text files. Ojai is a weird one. It's not a food pun, as far as I can tell. It's a set of plugins that collect system configuration data, kind of similar to Factor on Puppet, if you're familiar with that. And these little bits of information are then provided to Chef so that it can make decisions. And this might be things like the OS version or hardware specs like the RAM or the disk space, whether the system is virtual. You can write your own Ojai plugins to gather bits of information that you may need. For example, you could have an Ojai that looks at the logged in user and then compares that against some directory service so that you can, so that Chef can then make decisions about what to install based on group membership, for instance. There are other components in Chef that I'm not going to get into because they kind of mostly deal with the development side and the workstation product. But for the purposes of this talk, I just kind of wanted to stick with the management side. So let's quickly go over what happens when Chef runs. First, the client starts and builds the node attributes using Ojai and gathers all this information that defines your system. For some attributes, it uses information that it gets from Ojai. Other information it might get dynamically during the Chef run as well. Otherwise, it'll just look for static configuration bits within Chef to use to make decisions about what to do. Chef then reaches out to the defined server, and it may register itself using that private public key if necessary, and that way the server knows, can verify the identity of the machine. Once it establishes a connection, it downloads any changed cookbooks, or if it's the first run, it just downloads everything, and it collects everything into its cache, and it'll only sync down cookbooks and recipes that have changed in the interim. Chef then evaluates all of the cookbooks and compiles every resource that it finds. This includes updating any of those node attributes that were defined by Ojai or within Chef, and it'll load any Ruby libraries or files that you have defined within your cookbooks as well. During the conversion state, each resource is mapped to a provider, which will take action to make any changes necessary to bring the machine to your desired managed state. And finally, Chef client will finish up after running after converging, And we'll run notification handlers, which you can use to post logs, lay down static or lay down files with user state data that can later be slurped up with your log aggregation tool like Splunk or OS Query. And then the notifications handlers will also post some of that run data back up to the Chef server to store as metadata in your node object. So I want to move on and talk about a little bit how we utilize Chef at Facebook and how we kind of customize a few things to make life easier for us and allow for our users and our customers to make decisions about how their own systems are being managed. There's a few reasons that we do this, what we call the API model. One is that it can foster a feeling of ownership amongst the users. If they feel like they have a leg in the fight, they will be more willing to accept management of their systems. It encourages buy-in from a user base who are used to working with APIs in their day job. We deal mostly with developers in our user base. We may not, as IT, may not always know the appropriate setting or app that needs to be applied to a system or a class of systems or a group of users. That decision may be up to the user themselves or their manager or a PM or HR or security. And we also may not, we're not the ones making decisions about some of the security settings on the systems. And so the same API model that we provide for end users to kind of affect changes on their own system, we also give to other groups such as security, in which they can use to make sure that the security tools that they want to be installed and managed on the systems are up to their standards. And what makes this so easy to do in Chef is that everything is plain text. It's all in code, and it's all in version control. It makes it easy to audit, easy to share ideas, easy to pass information back and forth, to reuse code. All changes that we apply internally require peer review, so nobody can, say, change a setting on their own system without getting at least one other person to sign off on it and review it for them. Some changes we may require users to provide further justification or context about what they're trying to do. Some security-related configurations may go specifically to security groups to do the review themselves and talk with the users about what they're trying to do. So yeah, it's super easy. All you do is just write up a bunch of Ruby, save it to a file, put it in the correct location, get one of your buddies to sign off on it, and then the next thing you know, the entire company has a new message of the day in their terminal. Everybody's happy, their colors are converted on their screen, mayhem ensues. But we'll get to that. It's not really that easy. First, I kind of want to go off on a little tangent here and talk about a different topic, which is ice cream. How many of you have been to the creamery this week? How many more than once? Greg? Yeah. How many have already gone today? Greg? How many wish you were there right now? Yes. Me too. Visiting the creamery, as you know, is a time-honored tradition here at Sumac, as is trying new flavors. I'm boring. I usually just like plain vanilla. Although, if I'm honest with myself, whatever that peanut butter thing was last night was really good. But the good thing about places like this is you can customize the flavors as you so desire, right? So you can think of chocolate or vanilla as kind of the base configuration that applies to all attendees who are visiting the creamery. And then the customized flavors are user or node customizations that they are applying to themselves, to their heart's content, and depending on the time of day, the group that you're with, demographic, your preference, your mood, the weather, it comes down to you can customize to your heart's content, like these two. If you don't know Gil and Mac This is the Dropbox IT Brain Trust. So I'll pause a moment while everybody sells their Dropbox stock. So what does this have to do with Macs? Well, in computer science, there's a concept of inheritance and convergence. As Mac admins, we encounter this with our config management tools. You may want to make a configuration that's available to one computer be available to many computers. You might want a baseline of configs that apply to a group of computers, but then have a subset of those computers receive a different baseline of configurations. Or maybe you have different hardware types or classes which require different types of configurations of their own. Or you may want to apply your settings not only to computers or groups of computers or types or classes of computers, but also to users or groups of users as well. And traditionally, the way that we did this in the Mac world was through MCX with directory services to enact those changes. Does anybody remember working with MCX? Yeah, good times. Via directory services, configurations could be applied according to groups of users, groups of computers, to a specific computer or to users on those computers. And that inheritance model was mainly in that order. Configurations would apply to groups of users, which was the most generic setting. And then moving along, it would be applied to groups of computers, which would take precedence over the previous settings, down to individual computers, and finally, configurations defined for specific users would take precedence over any preceding setting in that flow. Does anybody remember what this, or know what this represents? Golden triangle? Yeah, so for those of you who are new to the platform, you may not remember this, but there was a time, and I'm glad that you're all sitting down, but there was a time when we used to bind our Macs to Active Directory, which is terrifying. And we would not just bind Macs to one directory service, we would bind them to two directory services. And the OS would then attempt to converge settings from Active Directory and Open Directory and apply those settings to the Mac. But you might notice that this is a triangle. There's 3 corners in the triangle. There's only 2 angles accounted for here. That's because technically the Mac had 3 directories, including the local Open Directory on the system itself. And some of the more clever admins in this room took advantage of this and created what was called a local MCX configuration methodology, which allowed you to slipstream settings directly onto the system locally without the need of a directory service. And that's all well and good. But then Apple came along and kind of upended their own cart by introducing and moving much of this management to configuration profiles. And while configuration profiles are easy to create and deploy, whether via an MDM server or using Tim Sutton's MCX to profiles package tool, or manually via the profiles command, we do lose some of the flexibility that we previously had with MCX, particularly the inheritance and convergence model that we were able to use. Profiles are a little bit more of an all or nothing situation. So what do you think would happen if you tried to apply multiple configuration profiles that manage the same preference domain to a computer? Probably nothing good, right? You may end up with merged configs. One setting may supersede another, not in the order in which you anticipate. But no matter what, it's not predictive, and it makes it way more difficult to troubleshoot and test. What if your chosen MDM decides to write out additional payloads to your config profiles without your knowledge or consent? What do you think would happen when you push those out to your systems? Again, probably nothing good. This may result in a configuration collision. Settings that you don't anticipate being managed are now being managed. Users may or may not be locked out of their machines at this point, and you don't know what's going on. There's no real easy way to manage preference domains with a set once in configuration profiles either, so you can't really lay down a config profile and then allow the user to later go in and make a change to that preference to their own liking. What about when you add user level profiles into the mix, or trying to generate custom settings with configuration profiles based on specific hardware type? Again, it's probably a terrible idea. Now, am I saying that managing Macs purely with config profiles is a terrible idea? Yes, I am. But that's clearly the direction that Apple is going, and so we need to be aware of these challenges that we face and be prepared to provide feedback and try to get things back on track. But that's later. This is now. We still have the ability to run root agents on our systems for the time being. We can take advantage of the inherent behavior of Chef to control the configurations that get applied, and we can base those decisions based on some of those same criteria that we were able to use in MCX, like groups of computers, individual computers, or groups of users, or individual users. So again, this is a kind of an anatomy of a Chef cookbook. These blocks represent file structure within a cookbook. Everything is in a static file structure, so it's pretty easy to figure out. The details of that aren't really important for the talk, but keep in mind that the anatomy of Chef can have a deterministic and structured format, so you can take advantage of that to apply your settings to the systems. I'm only going to talk about a few of these in here for this portion of the talk. Attributes can be thought of as kind of initializing settings. Many times in our API model, we just initialize everything as nil or empty. And this is where you would set your baseline config settings and maybe declare names of values within an array. Recipes are where you can affect changes to those base settings. So as Chef runs along, some of those values may be updated based on the serial number of the machine or the username. And that's where the Chef API model comes into play. And finally, resources are where Chef converges and actually applies everything to disk. The reason that we can deterministically make config changes during a Chef run is that Chef actually does 3 passes during a run, and I think it's technically more like 5 or 7, but my brain just shuts down after 3. When Chef runs on the client, the first thing it does is it loops through all the cookbooks, and it looks at all those attributes files inside each cookbook and gathers up any data that is in those attribute files and collects it all into one giant node object in Ruby. Then Chef will go back and loop through the cookbooks again, and it adds data. Any updated variables for those attributes, it will merge into that data object, so essentially overriding the previous iteration of that value. And this is where that inheritance and convergence model begins to come into play and make sense. And finally, Chef loops through everything again in what is sometimes called the runtime or the convergence mode. And this is where Chef will use resources and providers to write the changes to disk, or install applications, or create files, or users, and whatnot. And since the last setting that existed in that node object wins in this case, we can be deterministic about what that value is going to be on any given piece of hardware. So this is a very watered down run list of recipes. And because Chef has a predictable order, it will run through all of these in the order in which you state. So if you want settings that apply to the entire fleet of machines, you want those to be pretty early in the run list, so they would go into the base settings here. And then as Chef rolls through the rest of the recipes, some of those attributes may be updated. And then at the end of the run list, you may want to narrow it down as far as the individual computer or the individual user on the system. So to run through the steps again, at the very base level, we set a config in the attribute to be nil or empty. That's because if there's no setting, then we don't want anything to actually take place. When Chef comes back around and processes all of the recipes, one of those recipes might change a particular attribute, maybe from false to true or from empty to having some value. And then finally, when Chef converges during runtime, the last known setting in the attribute wins, and your system, the system setting will be applied to disk. So hopefully this will begin to make a little bit more sense. I'm going to run through a couple of examples here. In this example, I'm going to customize a login window configuration profile. These settings represent node attributes in the CPE login window namespace inside that cookbook. And this is an open source cookbook that Pinterest has on their GitHub that I'm using here. By declaring these values as nil in the attributes file, we're creating an empty node object. And if that setting, if those values don't get changed at any other point during the run, then when it comes time to converge, Chef will come along and say there's nothing to do, so no profile will be installed. So now that Chef has compiled all of the attributes from all of the recipes, it loops back around, remember, and it looks in all the recipes again for any changes to the attributes based on criteria that we control. So in this example, in that base settings recipe from the run list, we are changing a few of the values for the login window profile to no longer be nil or empty, but to have value that will be used when it builds the config profile. So here we're just managing I think it's the user and password boxes instead of the icon. We're setting it so when you click on the upper right-hand corner, you can see the IP and the host name, and we're hiding admin users below 500 on the system. And any other configurations that were set to nil in that attributes file are just going to be ignored. So when your config profile is created, it will only contain these values that have a positive value. Now, as Chef continues to compile and go through all the recipes, it may come across a new value to be either updated or added to that node object, to that array. And this is how you can override or include your own settings into the profile as you see fit. And remember, we know the order in which these recipes are compiled, so many times you can add this to your user customization or your node customization, which is basically just your username or your serial number, and then Chef will apply that to your system. In this case, I've customized the login window banner to include some really terrible Rush lyrics, which does mean that because I built this example, I ended up deploying terrible Rush lyrics to tens of thousands of Macs, which is kind of fun. Now that compile time has finished, Chef loops back through and converges during the runtime. When it gets to the CPE login window recipe, it calls a resource, which calls a provider, and it passes this object, this array of data, to that resource. The resource says thank you, takes it, and it uses its own logic to build that profile and install it on the system. And then you can check your work, in this case, by logging out and getting a terrible Rush song in your head. Here's an example using Spotlight exclusions. Normally you can add exclusions by just dragging them into this list, but this can also be done programmatically as well. Here in the attributes file of CPE Spotlight Cookbook, we're again setting the default value to nil because we don't want anything to be applied when Chef runs unless some other recipe makes the decision to have a value added. Because it's an array inside of a hash, it's basically just a list of folders. We're declaring it empty rather than nil. That way it won't get confused later when we try to add something to that array. In this case, we don't have any base settings that we want to apply to any system, so it remains nil throughout most of the chef run until it gets to the customizations, in which case any user may want to have this applied to their system or to their user, their logged in user. But the cookbook is still part of the compile and runtime, and it still builds that node object. It just builds it as an empty array. In this example, I'm declaring that I want the source folder inside my home directory to be included in the Spotlight extensions so that it is not indexed by Spotlight. Just by setting this to any value other than nil, you're making sure that Chef will take action on that object when it gets to the convergence time. And I did this on purpose. The point is not to read this slide, but to illustrate that you don't really need to know what's going on in the resource. All you need to worry about is just the data that you're passing to it, and the resource takes that data, builds the end result the way that you define. This is an open source cookbook, and so all you really need to know if you download this cookbook is what values you have to pass to the resource. You don't even really have to ever look at the resource file itself. And then when Chef runs, we can see that that source folder has been added to the Spotlight privacy pane in the Spotlight system preference. Because that node attribute was an array, we could have added any number of file paths to that array, and then it would have just added each of them to this list. One thing that the Chef API models allows us to do is define kind of a test path for applications that we install. Here's an example where we, in our CPE Monkey Tools cookbook, where we declare the version of Monkey that we want to install across the fleet. And you can see we're declaring it again as an empty array here, or an empty hash, so that if we don't have any intention to install Monkey, Chef won't do anything when it comes time to run. Now again, in our base settings, we may define a baseline version, a stable version of Monkey that we want to install across the fleet. And if this is the only setting that is applied through the Chef run, then this is the version that will get installed on every Mac under management in your fleet. However, we do have a test group internally called Trusted Testers. This group consists of a few thousand users who have agreed to sacrifice the stability of their machines to help us test out bleeding edge software. And so here in the Trusted Testers cookbook, we are overriding those node attributes with new values, new versions of Monkey that we want to install on those few thousand machines. And again, because we know the order in which Chef runs, we know that base settings comes before Trusted Testers, so anything in Trusted Testers will essentially overwrite anything in base settings in that node object. So when Chef converges, anyone who is in the Trusted Tester group will receive the test version of the software that is being installed by Chef. And for a final example, let's look at Nomad. You're probably familiar with Nomad. You can't miss Joel walking around and vamping through the conference. Nomad's a menu bar utility that can be used to link your local user to an associated AD user account without the need to bind your Mac to AD, which again is a terrible idea. But that's not all Nomad can do. It can also provide us with customizable menu bar actions under the Actions menu, under the Nomad icon. Shown here is a Fix My Mac selection that when users choose it, all it's doing is running Chef. It opens console so they can see the output and feel good about what's happening on their system. So again, in the CPE Nomad cookbook, we declare everything as nil to start out with because we don't want to have any baseline configurations applied if we're not managing Nomad on a system. In the base settings, we define the Fix My Mac action item. Here we've given it a name. We give it an array inside the action with a command and a command option. In this case, we were just simply running a script. I think this was an earlier version that would just load terminal and run the script itself. But this, again, is in base settings because we want this to be applied to everybody, right? But then, to illustrate how we can continue to add things and slipstream stuff into the node object, I've set an additional action item here in my user customization. And this define action will send a string to the macOS notification center in the upper right hand of the screen. And again, when it comes time to compile, Chef will have added my customization to the node object and will install both the Fix My Mac action item as well as whatever I've defined as my own action item that I want to have. And this comes in handy. I think we've had folks from the help desk add their own action items under Nomad. We had somebody add some cert creation tool underneath there for a specific use case that applied to only a very small subset of users. So this sort of behavior in Chef where we can dynamically build profiles on the user's systems becomes really handy when you're working with something like Nomad. And then after Chef is done, you can look under the action submenu under Nomad, and on my system, I would see an action item called Send Notification, which if I click, gives me a very important reminder that I need to remain productive during the day and get back to work. So to quickly wrap up the slides, we can initiate those settings that we want to apply to systems as nil or empty, in which case Chef won't do anything with that data. And then when Chef comes back around and does the compile time run of the process, it may look for or gather updated variables to add to those node objects. And if those objects do contain data when Chef converges during the runtime, it will apply those changes to disk. And that's how we use the Chef API model to apply configurations and distribute our workload out to our users and our customers. So that's a lot of talking. I'm going to do a quick demo. And again, this is there's a gist with instructions if you want to follow along. And hopefully this will work, right? This will work, right? Oof. How's that look? Terrible, doesn't it? Is everybody still dreaming of ice cream? Okay. So here's the instructions. We're basically going to customize a few configuration profiles to install. And these settings are non-destructive. Nothing will blow up, but I would recommend doing this in a VM, especially if you're already managing your system with another system or another config management. The only thing you need to do is download and install Chef and make sure that Git is installed via the command line tools or through some other source. And then you can git clone the 3 repos. And I have already done that because I don't trust the network. Ooh, look at that. Okay, and there's no profiles pane in system preferences, so I'm not tricking you. So we already copied that, so now we just need to copy, or we've brought down the Git repos. There's one there. There's the gist. And now we just need to copy the files into the correct location. And I'm going to update the company name because I don't want it to be called my company. We need to edit our init cookbook to ensure that these 3 cookbooks that I have copied over from Pinterest will be included in our run list. And I am also going to delete Chrome because it is behaving oddly. And then we edit the run list itself to include those recipes that we copied from Pinterest. And again, let's get rid of Chrome because I don't like it. So there's a bug. Of course, there's always a bug, right? In 10.13, running in a VM, invoking, I think, syscontrol or something causes kernel panic. So we're going to edit our OHI to disable a few plugins, which will allow us to not kernel panic. And then we go into the correct location. And here's what the node customization is doing. Basically, I want to configure a profile with a screensaver timeout, change it to 20 minutes. I'm going to add a launchd that does nothing, just echoes nothing. I'm going to configure a profile that sets the desktop picture to some path. Configure Spotlight exclusion because we don't want our users opening the Chess app from Spotlight or directory services from core services. We're going to configure a profile to orient the dock on the left and add the applications to the dock, and create a profile to configure the login window settings, and a profile to manage the application blacklist so that users cannot open the App Store, which is good fun. All right, is this going to work? Anyone? See the desktop's being changed. The dock will move to the left here in a second. We've got magnification on, the applications were added, and that's it, it's done. And we should have a pane in system preferences showing profiles. There they are. We have our application restriction for the App Store, desktop wallpaper, the dock being oriented on the left, login window settings, and a screensaver. And just to prove that Chef is idempotent and dynamic, if we run it again, you'll see that banner text change because it's just choosing from a random list of Rocky quotes. And then again, I probably put way too many quotes in here. There we go. And that's that. And then when it comes time that you no longer want to manage these systems, you can just remove that cookbook, remove that customization, run Chef again, and we'll see these profiles start disappearing if everything works correctly. And the desktop will move back, or the dock will move back to the bottom. The desktop will go back to the built-in picture. Well, it might. There you go. And then it got rid of all those profiles. So the good news there is that you're not littering systems with profiles that were previously managed. If you no longer want to manage that profile, the CPE profiles resource that Nate and Mike wrote will go back and clean that up for you and remove it from your system. And that is it. questions? Does anybody want to go watch the rest of the World Cup game with me?
Can we do it at the creamery? Ice cream.
Yeah. Do they have monitors there?
Joe, how do you deal with the profiles that have
Heads up.
how do you deal with config profiles that have payloads that are like UI MDM now?
You don't. Anything that requires an MDM to install. Theoretically, you could install it, but if it doesn't meet the UAMDM specification, then those payloads may not be doing what you think they're doing. So it's best used in conjunction with an MDM for sure.
Gotcha. Are you guys going to be doing any sort of like work to try to integrate it with like an MDM where it can kind of utilize the resources that Chef has and like?
Maybe. Jesse might have a different answer than me, but my take is that we want to use the appropriate tool for what you're trying to do. So anything that's UAMDM or for like the texts, you mean, I would say it's more appropriate just to use MDM for that than to try to shoehorn that into some config management. I know Eric Gomez has written a blog post recently about how he was doing dynamic config profile creation with an MDM via Chef, which sounds awesome. I kind of don't really understand what he was doing. But the idea there is that using your MDM's API itself, you can customize settings kind of in a similar way to how we do it locally on the machine. Customize those settings and have that then installed via the MDM to the machine.
So the profiles that were installed by Chef were all unsigned. Is there a way that Chef can sign those profiles as well?
If you want to ship a key, sure. What does it really get you?
Happy faces.
Yeah. And you're also handing out a key to all your machines.
Right.
Got one down there. Sure.
How much more difficult, or your experience-wise, switching from, let's say, Puppet to Chef, or the differences between the two?
I haven't used Puppet, so I can't really say, and I have not done any migration to or from Chef. I migrated to Chef myself by starting a new job. I know that the folks at Slack, I think, did a talk at ChefConf about how they migrated from one management system to Chef, which I thought was really cool.
I believe Chef Server, like the webfront is you have to pay for it. You know, any free platforms, or like Foreman, for example, is for Puppet. But I know you could get Foreman to work with Chef, but it's not as straightforward.
Yeah, I really don't know. I don't know how that works with Puppet. I think some of the folks here have used Puppet and Chef. Does anybody have an answer? No? Nothing? Sorry. All right, I think that does it. Thank you for coming.